that is Brian's speed in miles per hour if he's driving 100 kilometers per hour. And you're done. 16. Fernando can run 1 mile in 4.5 minutes. What is his speed in miles per hour? So what did they give me in this case? They gave me mile and minutes, and they want miles per hour. So in this case, I already have miles, right? That's what they gave me. What I need to change is minutes to hours. Okay, that's what I need to change because they want miles per hour. So I'm going to start with 4.5 minutes. Oops. 4.5 minutes over X hours to identify how much is that in hours. Equals, I need to use another ratio here of what I know about minutes and hours, how they relate to each other, right? So like in the last problem, number 15, they gave me that. Kilometers and miles is 1.16 kilometers is the same as 1 mile. But in this one, they're not telling me because you should know the connection between minutes and hours. There are 60 minutes in 1 hour. Right? Minutes, hours. Same as the original ratio. Minutes over hours, minutes over hours. We're going to cross multiply to solve. So multiply in this direction. We're going to get 60x. Right? X times 60 is 60x. 4.5 times 1 is 4.5. We're going to divide by 60. So x equals 4.5 divided by 60. Calculator says 0.075. Remember, this is hours, right? So now we want to find his speed in miles per hour. That's not his speed. That's just how many hours is 4.5 minutes. 4.5 minutes is 0.075 hours. So they're saying that he can run 1 mile in this much time. So that means that he can run 1 mile in 0.075 hours. I need to do the division here for 1 divided by 0.075 in order to actually get his speed. Right? And when you're going to write speeds, any rates, you need to have a 1 in the denominator. So basically you need to divide. 1 divided by, according to my calculator here, 1 divided by 0.075 is going to be 13. It doesn't say to round to what, so I'm going to do to the hundredths place again. 13.33 miles per hour. That is Fernando's speed. If he can run 1 mile in 4.5 minutes, that means he's running at 13.33 miles per hour. 17. Solve the equation y equals 3x plus 2 for x. So isolate the x, basically. Here we go. Like that. We're going to first figure out where the x is, which is here on the right side. We need to isolate it, so first I'm going to kick out the 2. We're going to subtract 2. So 3x, y minus 2, divide by 3. X equals y minus 2 over 3. And you're done. That's it. So subtract the 2. You do not combine these two because they're not like terms, so I wrote y minus 2. And then divide by 3, and then all I did was just put the 3 underneath both of them. Okay, so you can write the answer as I wrote it like that, and write the x on the left side. Y minus 2 over 3, that's correct. Or you might choose to put the 3 below, underneath each of the terms, so it's going to be x equals y over 3 minus 2 over 3, like that. Both of those would work. 18. Solve the equation 3x minus 5y equals 15 for y. So the same thing. I want to solve for y. First identify where the y is, right there. So that means get rid of the 3x first. We're going to subtract 3x. Why the 3x and not the negative 5? Remember the rules. You get rid of the stuff that is farther away basically first. So the negative 5 is being multiplied times the y. That's last. This number is being added, subtracted, so that's going to be the first one to go. Okay, so the 3x and the negative 3x cancel. Negative 5y. On the right side, you can't put those together, right? It's 15 minus 3x or negative 3x plus 15, which is the same thing, okay? So some of you guys might choose to write 15 minus 3x. Some other people might choose to write instead negative 3x plus 15. Those are the same thing. Those two are the same thing. What is not okay to write is this one, 3x minus 15. That's completely different, right? See the difference there. The 15 is positive, the 3x is negative. In this one, then the 3x is still negative, the 15 is still positive. But in this one, you have changed the sign. So this one would not be okay. But either one of these two would be correct. Let me erase this one. And continue. So I'm going to keep the one on top that I already did. 15 minus 3x. Next, what you're going to do is divide by negative 5. Divide this by negative 5. And there you go. Y equals, what I'm going to do is I'm going to write the negative in front. 15 minus 3x all over 5. Negative 15 minus 3x all over 5. That's correct. You might choose to leave it like that. You might also choose to divide each one by 5. So you might say, I'm going to take the negative 5, I'm going to divide 15 divided by negative 5, and negative 3x divided by negative 5. That also might be correct. So if you do that, your answer might look like this. Y equals 15 divided by negative 5 is negative 3. Negative 3. And then negative 3x over negative 5. Negative over negative makes it positive. So plus 3 over 5 cannot be divided, so just 3 over 5x. That's also correct. And also, if somebody had chosen, like before we said, maybe somebody chose negative 3x minus plus 15 instead of writing it like this. So then these would be flipped. That person maybe got this answer. Y equals 3 over 5x minus 3. That's also correct. There's a lot of different ways to write it. You just can't choose random numbers though, right? So those are all correct. Okay, 19. Andy is trying to complete as many community service hours as possible to earn the national award. Last month, Andy spent 24 hours at the hospital. The rest of his hours were divided evenly among the animal shelter, the preschool, and the garden. Andy logged 8 hours at the preschool. Okay, so last month, Andy spent 24 hours at the hospital. So he spent time at, I'm going to write this down just so I could keep everything straight. Hospital. And also at the animal shelter, we'll call it the AS, and also at the preschool, we'll just call it pre, and also at the garden, we'll call it garden. It's not that long of a word. And that gives him his total hours for the month. Some hours at the hospital, some hours at the animal shelter, some hours at the preschool, some hours at the garden. That gives him his total. Write an equation to model this situation, okay? So what is unknown is the total, right? Andy logged 8, possible. The total is what we don't know. We also don't know the garden or the preschool, but we're going to actually figure those out. I mean the garden or the animal shelter. So the total is the unknown. We're going to call that X. We know how many hours he logged at the hospital, 24. We don't know how many hours he logged at the animal shelter. We don't know how many hours he logged at the preschool. We don't know how many hours he logged at the garden, right? We do know that they're all the same. Why? Because it says the rest of his hours were divided evenly among the three. So the same for the animal shelter, the same for the preschool, the same for the garden. Okay? Those are the exact same number of hours for each one. So it's going to be 24 plus animal shelter, preschool, and garden. They're all the same. Can we call them all Y? Y, Y. Since they're all the same. So it's going to be plus Y, plus Y, plus Y. Put them together and it's 24 plus 3Y equals X. There you go. In this case, Y stands for the animal shelter, the preschool, or the garden. They're all the same. They're divided evenly. X stands for the total number of hours. And now we can solve it. That's an equation that we can use. B, how many hours did Andy complete last month? We know because they told us how many hours he logged at the preschool. So if he logged 8 hours at the preschool, that means the same number for this, the same number for this. So just plug in 8 right there, and you're done. 24 plus 3 times 8 equals X. 24 plus 24 equals X. So his grand total was 48 hours. There you go. Okay, 20. Ava paid her mom $350. The rest of her paycheck was divided evenly. Once again, there's that word evenly. Towards her cell phone bill, car insurance, and savings account. So that means she paid the same amount to the cell phone, to the car insurance, and to the savings account. Ava's cell phone bill, not bias, it should say bill right there, was $75. Write an equation to represent this situation. So once again, I'm going to start the same way. We know how much she paid her mom, $350. But then on top of that, she paid the rest of her paycheck evenly towards 3 things, right? Cell phone bill, car insurance, and savings account. Each of those are the same thing, so let's call them all Y. Just again, Y, oops. Cell phone bill is Y, car insurance is Y, savings account is Y. Y amount because they all are the same, divided evenly. So there's 3 of them. So 350 plus 3Y equals her total. Write an equation to represent the situation. Her total is going to be X. Or you might choose that X is the amount that she's paying evenly and Y is the total. Either way. So 350 plus 3Y equals X. We're going to plug in the number that they gave us. It says Ava's cell phone bill is 75. So if this is 75, that means that's 75 and this is 75. So just plug in 75 to get your final answer. So it's going to be 350 plus 3 times 75. 3 times 75 is 225. So it's 350 plus 225 equals X. The grand total then at that point is going to be 575. That's how much she paid from her paycheck. Oops, I kind of got ahead here, right? Write an equation to represent the situation is this. Solve it is this. So this should go down here. All this work should go here where it says how much was Ava's paycheck. Okay, 21. Solve the compound inequality and graph the solution. Okay, so solving a compound inequality means isolating the x. Sometimes it's an and inequality. Sometimes it's an or inequality. The basic idea is that 2 inequalities in the same problem. So in this one, this is an and inequality because I see that there's an x in the middle, right, in between the 2 other values. So we're going to solve this one by simply isolating the x in the middle by itself. Here we go. That's what I mean by this. We're going to basically leave the x by itself in the middle, which means get rid of the 7, get rid of the 4. So I'm going to subtract 7 first. But in this type of inequality, you got to do it to all sides. So you got to do it on the right side. You also got to do it on the left side. This cancels, so it's just 4x. My inequality symbols stay where they are. On the right side, 23 minus 7 is 16. On the left side, negative 5 minus 7 is negative 12. Okay, second step here is to divide everything by 4, right? You want to get rid of the 4. So divide by 4, divide by 4, divide by 4. On the left side, negative 12 divided by 4 is negative 3. The middle is just x because the 4 cancels. And on the right side, 16 divided by 4 is just 4. So negative 3 is less than or equal to x is less than 4. That is your final compound inequality that you get. What does this mean? It means that x, the value of x, is somewhere between negative 3, including negative 3, and 4, not including 4 because there's no equal sign there. Okay, so in order to graph it, what we're going to do is we're going to draw a circle at negative 3, another one at 4, We're going to choose to either to shade them or not. That's called closed or open. This one is going to be closed because of the equal sign, so I should shade this one in. The other one's going to be open because there is no equal sign there, see? So we're going to leave it like that. And finally, for all and inequalities that look like this, that are and inequalities, you're always going to shade in between the two numbers. So we're going to shade in between the -3 and the 4. You can choose to shade like this, or some people choose to do this. It's the same thing. It's basically saying that x could be any number between -3 and 4. So x could be -2 or -1 or 0 or 1 or 2 or 3 or 4 or any number in between them, right? It could be a decimal. It could be -0.5. It could be -2.4. It could be 3.9. Any number between there. Okay, number 22 is another compound inequality. Solve the compound inequality and graph the solution. 3x plus 1 is less than -5, or 2x plus 7 is greater than or equal to 15. In this case, what we have is an OR inequality. For OR inequalities, you just have to solve both parts of it, this one and this one, separate from each other, and to get both of the solutions. Okay, so I'm going to solve the left one. 3x plus 1 is less than -5. First, by subtracting 1, so it's 3x. -5 minus 1 is -6. Then I'm going to divide by 3. X is less than -2. Or, right, I'm going to do the other side now. 2x plus 7 is greater than or equal to 15. We're going to subtract 7. 2x is greater than or equal to 8. 15 minus 7 is 8. Divide by 2. And so x is greater than or equal to 4. That's your answer there. I'm going to write it over here. X is greater than or equal to 4. That way it's part of this one. So that's your solution. X is a number that is smaller than -2, or maybe it could be greater than 4. X is a number that is smaller than -2, or maybe it could be greater than 4. So we're going to draw two circles, one at -2, the other one at +4. And this is an OR inequality, which means that they have to go in opposite directions. This one is saying that x is a number that is smaller than -2, so we're going to shade this way, like that. The other one is saying that x is a number greater than or equal to 4. Notice the equal sign there. We're going to close that circle, and then go that way also, like that. And that's what should happen with OR inequalities. They should be going in opposite directions. Okay, 23. The graph shows the distance a car travels throughout the day. So you can see that the horizontal axis represents the time that has passed in hours, and the vertical axis represents the distance in miles that the car travels throughout the day. So let's answer the questions. It says, how does part 1 of the graph, part 1, compare to part 2? You can see that both of them, the distance is increasing, right? Which means that the car is going away from wherever its starting point was. But in part 1 is steeper than part 2, right? If you were to try to walk on these lines, let's say you're a person walking on these lines, which one would be more difficult to walk on? That one, right? That one is steeper than that one, which is a little bit flatter. So what does that mean in terms of the car? It means that the car is going faster here than here. So that's what we're going to say. Part 1 is faster. The car is going faster. And part 2 is slower. B. How does part 8 of the graph compare to part 9? Same idea, 8 and 9. Notice that they're both going down now, which means that the car is returning to wherever its starting point was. But in this one, it's a little bit flatter. This one is a little bit steeper, right? So you can see this is steeper than that. If you were to walk on these, which one would be easier? This one. That means that the car is going slower here than it is here. The steeper it is, the fastest it's moving. So part A is slower. We can say in part A, to be more correct, the car is moving slower. Which is what we should have said on part A over here. right here. In part 1, the car is moving faster. In part A, the car is moving slower than in part 9. Next question, what is significant about parts 3, 5, and 7? So if you look for parts 3 right here, 5, and 7, they look like flat lines, right? What does that mean in terms of the car? It means that the time is still moving, right? They're flat. That means the time is still moving, but the distance has not changed, which means that the car is stopped. The car is stopped. Or it took a pause, okay? It stopped somewhere. Last question, what is the difference between part 4 and part 6? Here's part 4, here's part 6. In part 4, the car is moving away from wherever its starting point was. In part 6, the car starts going back to wherever its starting point was. Okay, so part 4, car moving away. Part 4, car going away from its starting point. Part 6, car returning to its starting point. Car is returning to its starting point. There you go. Okay, 24. Janet recorded 5 miles on day 1. She recorded 7 miles on the second day, 9 miles on the third day, and 11 miles on the fourth day. So this is a pattern, right? 5 miles, so it's 5, then 7, then 9, then 11. That's a sequence. If this pattern continues, what is the common difference in that situation? So first, part A, common difference. 5, 7, 9, 11. You can see it clearly, I hope. What is it changing by? 2. D equals 2. Part B, write an explicit rule for the sequence. Remember, to write the explicit rule, you need f of 1 and you need D. We have D, we already wrote it, so we need f of 1. F of 1 is the first term, which is 5. So using that, I can write the explicit rule, which is f of n equals f of 1 plus D times n minus 1. F of n equals f of 1 plus D times n minus 1. Plugging in the values, we have f of n equals 5 plus 2 times n minus 1. And there you go. That is your explicit rule. Part C. How many miles would be recorded on day 100? That means plug in 100. F of 100 equals 5 plus 2 times 100 minus 1 is 99. So notice what I did there. I plugged in 100 right there. So it's 100 minus 1, 99. Solve that. So f of 100 equals 5 plus 2 times 99, that's 198. So 198 plus 5 is equal to 203 miles. That's how many would be recorded on day 100. 25. Given the relation negative 4, 3, negative 2, 5, 2, negative 3, 4, 3, and 5, negative 1, list the domain. Alright. So the domain is the collection of all the input values, all the x values. So it's negative 4, negative 2, negative 2, 2, 4, and 5. None of them are repeated, so you write them all. If any of them were repeated, you only write it once. That's it for the domain. The range. The range is the collection of all the y values. So 3, 5, negative 3. There's another 3, but I'm not going to write it again because I already wrote it once. And negative 1. Question is this relation a function? Be careful what you're checking for. Remember, to check if it's a function, look at the inputs. Look at the x values, basically. Are all of them different? If so, it is a function. If any of them repeat, and they give you different outputs, that's not a function, right? Each input must give you the same output every time. So in this case, all of the inputs are different. This is a function. Yes. We're going to say yes. Each input, it says explain. So each input has one output. Right? The -4 only gives you 3. The -2 gives you 5. The 2 gives you -3, and so on. The 4 gives you 3. The 5, -1. Yes, there is an output that repeats, but that doesn't matter in terms of it is a function or not. 26, same thing. Let's list the domain. All the input values. -2. -2 again, I'm not going to write it again. I'm only going to write it once. -1, 1, and 2. Range. -1, 5, 6, 3, 7. Is this relation a function? Once again, look at the input values. -2 and -2 repeats. Here, -2 gives you -1, and here, -2 gives you 5. That's not allowed, right? Each input should only give you the same output every time. This input is giving you two different outputs, right? It's like in a mapping diagram, it's sending out two different arrows. It's sending an arrow towards -1 and another one towards 5. So no, not a function. It says explain once again. So my explanation is going to say that the input 2, -2, the input value -2 has two outputs. Has two outputs. -2 has two outputs. It goes to -1 and also to 5. So no, it's not a function. 27. Graph the relation y equals 1/3 x plus 2. To graph a relation, what we said is make a table every time, plug in some values. Notice that they already plugged in some values for us, so all we have to do is get the outputs to see what they gave us. Okay, so we're going to plug in -6, -3, 0, 3, and 6 in there. Here we go. Starting with -6. Y equals 1/3 x plus 2. I'm going to plug in -6. Now, since I'm multiplying times a fraction here, 1/3, I'm going to write it as -6 over 1. So -6 over 1. -6 over 1. That way I could do the multiplication. So do the calculation here, and I'm going to get y equals 1 times 6 is 6. 3 times 1 is 3. Positive times negative is negative. So it's -6/3 plus 2. -6 over 3 is -2. Plus 2 is 0. So -6 gives me 0. Let's do it again for -3. So I'm going to do this again for -3. Plug in -3 right there. Oops, again I'm going to do -3 over 1 just like the last one. So it's a fraction. 1/3 times -3 over 1. What I get is 3. 1 times 3 is 3. 3 times 1 is also 3. And it's going to be negative because it's negative times a positive times a negative. So -3 over 3 plus 2. -3/3 is -1 plus 2, which is 1. That gives you 1. Keep going. Let's do the next one. So I'm going to plug in now 0. So plug in 0 right there. That should be easy. Y equals 1/3 times 0 is just 0. Anything times 0 is 0. Plus 2 is 2. So that gives you 2. Plug in 3. Okay, let's plug in 3. Once again, I'm going to write it as 3 over 1. Positive 3 in this case, so don't have to worry about the sign. 1 times 3 is 3. 3 times 1 is 3 plus 2. 3 over 3 is just 1, so it's 1 plus 2, which is 3. And the last one we're going to plug in is 6. So plug in 6 right there. 6 over 1 again, fraction. 1 times 6 is 6. 3 times 1 is 3. Remember, when you're doing these multiplications, numerator times numerator, denominator times denominator. Plus 2. 6 divided by 3 is just 2, so it's 2 plus 2, which is 4. There you go. Now all you got to do is just plot those points. Okay, so remember the x value tells you to start at the origin and go left or go right depending on the sign. This one's telling you go left 6. The y value tells you to go up or go down depending on the sign. So this one's telling you to stay, don't go up, don't go down. This one says go up, right? All of these are positive, so they're all going to go up. So negative 6, 0. Negative 6, 0 right there on the x-axis. Negative 3, 1. Negative 3, 1. A little bit above. 0, 2. 0, 2. Right there. 3, 3. 3, 3. Right, 3 to the right, 3 up. And 6, 4. 6 to the right, 4 up. There you go. And we do connect these, okay? All graphs or functions that they give you where there is no situation are going to be continuous. Unless they tell you only use this domain, it's always going to be continuous. Okay, 28. Grace bought a car that had 450 miles on it. She drives 35 miles each day. Write a function that shows the number of miles on Grace's car after D days. Okay, so basically they're telling you to write a function. This is a sequence. On day 1, it has 450 miles. So f of 1 is 450. And D, the common difference, is increasing by 35, right? She's driving 35 miles each day. So using that, we can write a function, f of n equals 450 plus D, 35, times n minus 1. There you go. If Grace now has 1150 miles on her car, how many has she been driving? How many miles has she been driving already? Okay, how many days actually? If she already has 1150, how many days has she been driving? Okay, so that does not mean plug in 1150. Okay, it does not mean plug in 1150. What this means is the total is already 1150. What is n? What is the number of days that have passed if her total is 1150? So to solve this, what you're going to do is you're going to say f of n, the total is 1150. What's n? So they're telling you don't plug in n equals 1150. They're telling you plugged in a number and you got 1150. So we're going to do this. We're going to replace this one with 1150 and solve. So it's going to look like this. 1150 equals 450 plus 35 times n minus 1. I need to figure out what n is. To do that, I'm going to have to distribute. So 1150 equals 450 plus 35n, right? 35 times n is 35n. 35 times 1 is 35, but it's negative. And we're going to solve that. Okay. I'm going to continue right here, so I have enough space to continue working. 1150 is equal to, what I'm going to do is I'm going to combine the 450 and the negative 35 to make 415, right? 450 minus 35, 415. So 35n, because that one does not combine with anything, minus 415. Plus 415, sorry, plus 415, because it's positive 450 and negative 35. And that's basically a two-step equation that we can solve. I'm going to subtract 415, and so it's 35n equals 1150 minus 415, which is 735, and finally divide by 35. Divide by 35, and so n equals 735 divided by 35. That's going to be 21, correct? Let me check. Yep, 21. 21 days. So she has been driving for 21 days in order to get 1150 miles on her car. Okay, 29. Joy started her day with 15 happy memories. She makes 3 more happy memories each hour. Write a function that shows the number of happy memories Joy has after 8 hours. If Joy goes to bed with 80 happy memories, how many hours was she awake? Okay, so she started her day with 15 happy memories. That's f of 1 is 15. And D, the common difference, is 3. She makes 3 more per hour. So write a function, f of n equals 15 plus D times n minus 1. Actually, you know what? I'm thinking that I'm setting this up incorrectly, because if I read it more carefully, it says that Joy started her day with 15 happy memories. She makes 3 more happy memories each hour. So f of 1 is not 15. F of 1 means after 1 hour. She started with 15 before she even made happy memories. After 1 hour, she already has not 15, but she already has 18. So I need to change this to 18, because f of 1 means the first term, right? After 1 hour, she already has 18 because she already gained 3 more happy memories. So f of 1 is 18, D is still 3. So changing that also here will give me the correct answer. There you go. Now part B says Joy goes to bed with 80 happy memories. How many hours was she awake? So once again, they're not telling me plug in n equals 80. They're telling me what is n if the total is 80. So we're going to change f of n to 80. They're basically telling you the total happy memories for the day is 80. F of n equals 80. So we're going to replace this with 80. 80 equals 18 plus 3 times n minus 1. 80 equals 18 plus 3n minus 3. Combine the 18 and the 3. 80 equals 3n plus 15. Right? 18 and positive and negative 3 make 15. Subtract 15 from both sides. Subtract 15. Subtract 15. Right? Here's my equation. Cancel. So 80 minus 15 is going to be 65. Equals 3n. And then divide by 3. Okay, and 3 doesn't go into 65, so this must have been a typo. We're going to just leave it as a decimal then. It's going to be 21.7, 0.667, right? How many hours was she awake? Approximately 21.7 hours. Okay, and I'm going to stop this video at this problem right here because it's already kind of long. So I'm going to stop here and I'll do a second part video to keep going from 30 on to 30. What's the last problem here? 35? From 30 to 35, there will be a second part video for those. Okay, so we're going to stop this one right now.